Alright, some of you may need this review, some of you may not, but hopefully most of you got most of Chapter 1, Section 1. But I do want to review a few things, especially on the distance formula and the Pythagorean Theorem and how they're related. So I'm mainly going to talk about those, but I'll review some other topics covered in Chapter 1, Section 1. The basics, going all the way back from Algebra 1, is in our coordinate plane here. We have this as the x-axis, and then the vertical axis up here is the y-axis. And when we plot points, our x is listed first. So if we have something like 3, 5, this is our x value, and this right here is our y coordinate. So you come to the right, you start right here at the origin, where they intersect. That's called the origin. And we're going to go over 1, 2, 3, and then we're going to go up 5. 1, 2, 3, 4, 5. And that's our location of 3, 5. I'm going to call that point A just so we can refer to it as A. And then we'll put B at, I don't know, 4, negative 2. And so remember, to the right from the origin, this is the positive x-axis. To the left is the negative x-axis. Likewise, upwards, this is the positive y, and then down below, this is the negative y-axis. So we're going to go over 4, 1, 2, 3, 4, and then down 2, 1, 2, and we'll call this point B. Now, this brings us to the question, what is the distance between A and B? And we can't just count our blocks here, because if we were counting, if they were completely vertical to one another, completely horizontal, yeah, we could count them. But notice, if I take and draw a line going straight down from A and count them, we got 1, 2, 3, 4, 5, 6, 7. But if I swing it over to B, I have to make that line longer. So we can't just count it. It's more than 7 blocks long. So we can't use that method of counting that some students like to use. Instead, we've got to do there's a couple of options. The first is the distance formula. So you may remember the distance formula from geometry, and that is distance is equal to the square root of y2 minus y1 squared plus x2 minus plus x2 minus x1 squared. And all that's being square rooted there. Now, you may have learned it in a different version. You may have said y1 minus y2. Your x's may have been in this parentheses first. It doesn't matter because addition is commutative. So I'm just putting as y2 minus y1, as long as you're consistent. If you're going to call the first one 2 for the y, you call the first one right over here 2 for the x. Now I'm going to come up here. I'm going to label the first one. Point A is going to be x1, y1. And point B is going to be x2, y2. And then substitute those values in. So I get this. And I like to leave and substitute my values in last so I don't forget to put in that minus sign. Some students, especially when you have negative values in there, they forget to say minus a negative if that's what they need to do. And so, let's see, y2 value is negative 2. The y1 value is 5. The x2 value is 4, and the x1 value is 3. So negative 2 minus 5 is negative 7, and 4 minus 3 is 1. Square rooting this again. Sorry, I'm writing sideways here. So negative 7 squared is 49. Remember, a negative times a negative is a positive. Notice if you put this in your calculator, if you don't put it in right, sometimes it will give you a negative 49. So make sure if you're entering it in the calculator, you put it in as parentheses, or put it in parentheses like this. You'd say negative 7 like this and square it. So that's how you want to put it in the calculator. So 49 plus 1, and we're going to take the square root of that. And that gives you the square root of 50. And then putting it in simplest radical form, 50 breaks up into 2 times 25. Or the square root of 2 times the square root of 25. We know the square root of 25 is 5, so we end up with 5 square roots of 2. That is the distance. Now, 5 square roots of 2, punch that in your calculator, you can get a decimal approximation. It should be a little bit longer than what we counted over here earlier. But I want to go about this a different way, because maybe you don't remember the distance formula when you go to a quiz or a test and you've got a graph here and you're trying to figure it out. The other way we can do it is by taking it back to the Pythagorean Theorem. So let's remember the Pythagorean Theorem. I'll erase this. Here's eraser. This is a large eraser I've got, so bear with me. All right, so the Pythagorean Theorem is a little bit easier to remember. It's a squared plus b squared equals c squared. So let's write that down. A squared plus b squared equals c squared. Now, what did that go with? What shape? Well, it was a triangle, and more specifically, it was a right triangle. So whenever we use the Pythagorean Theorem, we need a right triangle to use. And that's exactly what we can make here with points A and B. We just need a third point. So that's one side of our triangle. And remember, it's got to be a right triangle, so I'm going to make it a right triangle like this right here. You could have also made a right triangle up here in the top right, but this is the way I chose to do it. So let's list out or count those sides. This is a side length of 1. This is 1, 2, 3, 4, 5, 6, 7 long. So this is a side length of 7. And so now this, we'll call it little side A, and this is little side B, and the hypotenuse, remember, is always by itself in the Pythagorean Theorem. That's C. And so now we can say 7 squared plus 1 squared is equal to C squared. 7 squared is 49, plus 1 equals C squared. So the square root of 50 is equal to C. And once again, we're going to get 2 square roots of 5 when we put it in simplest radical form. So notice how much easier that was. Most people can remember a squared plus b squared equals c squared. They don't have to remember the distance formula. But sometimes I might give you numbers that are way off the graph, and you can't graph it. But you can still use the Pythagorean Theorem to help you remember the distance formula. So if I rewrite this again, let's write it down below. A squared plus b squared equals c squared. Notice that, how did I come up with this distance of 7? We saw it on the distance formula. We said, you know what is this y value right here? I think we were calling this y2, and this is y1. If we subtract y2 minus y1, we get 7. Notice this point right here is 1, 2, 3, 4, 5 spots above. That's our y2, and this one's negative 2 below. So 5 minus a negative 2 equals 7. So we're subtracting one from the other, and instead of counting, you could just say subtract your y values. So subtracting our y values gives us a. So it's y2 minus y1, quantity squared is a. Same thing with b. Now this was an easy one to count 1 over, but if b was way out here and off the graph, you wouldn't be able to count it. So you'd say, what is that x-coordinate minus the original x-coordinate, and that would give you this side length. This b right here, that x-coordinate is 4, and this one right here is 3, so 4 minus 3 gives me 1. So that's where that came from. You're subtracting your x values. I'm going to bring down that plus symbol and subtracting the x values. Quantity squared. All that equals c squared. Guess what? If we get c by itself by square rooting both sides, so if I square root c squared, it just gives me c. So I'm going to replace that back with a c now. So I just square rooted the right side of that problem, but that means I got to square root the left side. And look, you've got the distance formula coming directly from the Pythagorean Theorem. The square root of y2 minus y1 squared plus x2 minus x1 squared is equal to c. The only thing is, instead of calling it c, they call it d for distance, and that's pretty much how we can easily come up with that formula without having to memorize all those things.